Hello and welcome to my talk on extending the support for SOAP-based web services using the tooling API. I'm Daniel Bellinger. I'm a developer for Fuse IT, an ISV partner based in Nelson, New Zealand. I've been developing on the platform since 2007. I think back then it was API version 8. Since then we've moved on at work. We're doing much more modern things like Canvas apps and a lot of integration projects with .NET based services, either them talking to Salesforce or Salesforce talking to them. And so we have a couple of products around that area, such as ones for Sitecore CMS and HP Trim. And that's a lot of what has driven the development of this tool that we're going to look at today, is the features we needed to be able to constantly work with SOAP-based web services and how they evolved. I'm also an active member on the Salesforce Stack Exchange, which I think is a great place to ask questions and get answers for Salesforce. So to sort of set the context, has anybody ever seen any of these types of errors when you're trying to bring a SOAP WSDL into Salesforce? These are the sort of things that we're going to be addressing. The top four are the sort of features that Salesforce doesn't directly currently support with the web-based version of WSDL-to-Apex, and they'll usually require you to go off and do some effort to get around them. And the bottom two, still errors that you can get using WSDL-to-Apex, but they're more environmental about your specific org. It may be that you've simply got too much Apex code in that org, or you've already deployed that class and you're trying to replace it again, and you're going to get errors along that line telling you it's already there. So in this session, I'm going to give you an overview of what the Fuse IT SFDC Explorer tool is, which we'll be using. And we'll recap exactly what happens, or what the flow is when you use the existing web-based version of WSDL-to-Apex in Salesforce. And then we'll do some demos showing how we can address a number of those issues we had on that first slide and how we can work around them using our custom tooling. And finally, we'll talk about how it was made using the tooling API. So the Fuse IT SFDC Explorer started off life as a very quick and dirty WinForms app, so it may not always be the prettiest thing. But it turned out, and it was a proving ground for tools that we were building in other places, and it was a quick place to put things together. But over time, a lot of those features actually turned out to be quite useful in and of themselves. So we have things like we can dynamically build SOQL queries using the metadata from the partner API. A lot of session management and tools for running debug logs and parsing them and running anonymous Apex. We're not really going to cover those in any great detail. This talk's all about the WSDL support within that tool. At this stage, it's a Windows-only tool. There is, however, a basic web version of the same tooling that you'll see in this demo. It doesn't have all the features, but it'll get the core part of it done for you. But you can get both of those from fuseit.com/explorer. I want to point out that this is a free tool, and I believe the expression is free as in beer. You can download it, distribute it, give it away for free. We don't give out the source code at this stage. So let's just go back through what the current process is if you've got a WSDL and you want to bring it into Salesforce using the web-based version of WSDL-to-Apex. The first step is, and I'm going to use a UPS address validation as an example here. You go off somewhere on the web, you find your WSDL, you download it, and you save it to your hard drive. Next, you log into Salesforce, go to your Apex classes, generate from WSDL. Then you locate that file you had on your disk and you upload it again into Salesforce. Press parse WSDL. Salesforce will validate that WSDL is syntactically correct XML, and then it will find the namespaces that appear in that WSDL and map them to Apex class names. You're free to come through there and change those as you need. You could even, if you want, map them all to a single Apex class. And then press generate Apex code. And all going well, you'll actually get links to those classes that were generated, and you can move on to that point that you're actually interested in, which is that last green step where you can add your remote site settings, and then you can start calling that web service and getting the work you're actually interested in done. There is a problem there, however, and that's not always the flow that you get. Quite often, you're going to find one of those errors that we had in the very first slide, and you're just going to sort of scratch your head and wonder, well, what do I do now? Where you often end up is in the secondary flow, this less than ideal flow, where you're going to have to start modifying that WSDL in ways in a hope that you can pass it back into that tool and then get the correct output that you wanted. Now, it might be something as simple as there was an existing class there and you need to either delete that or give it a new name. Or it might be that your WSDL has what's called imports or includes, which are quite common, where they've split the WSDL up into multiple parts, and you'll have to manually flatten those down into a single file. And then it could be something like the WSDL has both SOAP 1.1 and 1.2 bindings, and Salesforce is quite sensitive at the moment. The WSDL-to-Apex web version, it won't like it or reject it if you've got 1.2 bindings, even if the 1.1s are there and perfectly valid. Worst case, it might actually be that your WSDL is bigger than 1 megabyte. I don't know how, and the web version needs to be less than that. It's not much fun trying to shrink that 1 megabyte file down to get it within the limit. It's kind of like editing maybe a 500-page book, which is quite a big task. So all going well, you get your edited WSDL, you send it back through the process, and hopefully you get out to the end, or you might go through a few iterations. There's quite a risk that when you're in this unproductive flow, there's a good saying for what's going on here. It's shaving the WSDL yet. You're going to get more and more unproductive the more time you spend down there. And you might start out thinking, oh, I'm going to install this little XML tool and it will help me validate it or validate this WSDL. And before you know it, you've got a screwdriver out because you're going to put a new hard drive in because you run out of disk space and you don't want to, and you're just getting way off course. And your boss is like, what are you doing? So what can we do about that? We'll get into our first demo. So I'm going to open up SFDC Explorer, which should already be logged in. And it has a number of tabs. I've turned most of them off. The one of interest here is called WSDL-to-Apex. And there's two options to get you started. If it's a publicly accessible web service with WSDL, you can point it at the URL there, and it will start from that point. Or if you've got one saved to disk, you can start it from there. Just to give you a bit of context, I'll log into Salesforce and show you what happens with this WSDL that we're going to use. So we come down, we develop Apex classes, generate from WSDL. I've already saved it to my disk, and that's the UPS address validation one. So we open that. We'll go through those steps pretty quickly. We've mapped the namespaces. We're going to generate, and there's that error. So what are we going to do? Well, what's actually happened there is that WSDL has multiple parts, and let's have a look here. Here's that WSDL. We don't need to understand this too much, but basically the problem's up here. This message has two named parts. One of them is actually used for a header, and one's for the body. So Salesforce is actually quite capable of calling that. It just doesn't understand how that WSDL is structured. So let's take that same file and pass it to SFDC Explorer. There we go. So we're going to find that exact same file. We're in the wrong directory. There we go. And this should seem quite familiar. We've mapped the namespaces from that WSDL, and we've mapped them to classes. And you're free to come here and edit them as you like. We'll leave them with the default values. Proceeding on, this is a new step. And we're going to come back to this in more detail and cover what it can do. But basically, it's listing the web methods that are within that WSDL. So we'll generate Apex classes. And that will run through that WSDL and generate the required Apex code. And that should look, I'll see that a bit bigger for you. That should look quite familiar to a lot of people who have ever actually had to look at what code is generated by the web-based version of WSDL-to-Apex. It's got all the core parts in there. You'll be your port class and all the callouts to WebService, callout invoke, to actually make those calls. And it's also generated all the supporting classes, but nothing's actually been deployed to Salesforce yet. So if we wished, before we do the deployment, we can actually come here and we can make our required modifications. And now we can decide how we want to deploy that to Salesforce. We've got options of either deploying each class individually, or we can deploy them all at once. So we'll do that. And they've all gone out. I should point out there that you can see, if you understand the syntax of WSDL-to-Apex or web service callout invoke, that it has actually generated the required header for that request. So now we've got our code, we can move on to our green step, we can add our remote site settings to allow that call out, and we can actually start calling it again. But there's something missing there, something that's going to cause us a problem. Well, maybe not a problem, a lot of work anyway. We've generated hundreds, maybe thousands of lines of code. Before we can deploy that to production or put it in a managed package, we're going to need to write the code coverage for something that just happened in a few seconds, which is going to be a big effort for us. To do that, we're going to need to implement the web service mock interface so that we can mock our responses to that web service. And then we're going to need to test the invocation of each of those web methods that we want and look at each of the request and response types that are required for that, plus any supporting types such as headers that might be sent with the SOAP requests. So we've got another demo here showing you how we can address some of that. I'm going to reset this. Here I'm going to use the partner API simply because it's something that some people will be familiar with and it's readily accessible. So I'll select the partner API. It's got a few more namespaces in it, but we're just going to leave them as their defaults. You see here we've generated it's found a whole lot more web methods in that one. So what we want to do in this run is simply check generate test classes, and that will pick up some extra, that'll run our extra processes. Let it go. So as before, we've generated the main classes that we can use to call it. So I think we can find that there. Does that need to be bigger? Bigger. Where did it go? And then find again. So there's our main service class, and you'll see things like the endpoint, which is pretty familiar. The partner API actually has a ton of different headers you can define, but we'll skip over those. And then there's the more interesting parts, such as the web methods we can call. So I'm going to deploy all those. That's using the tooling API. We'll come back to what that's doing shortly. So that's great. We've got that there. I should point out that not only did we generate all the basic classes, but we've just deployed an implementation of web service mock that it also generated for us. A bit bigger. And that's implemented the doInvoke method for us. And at the start, it's just going to debug out what's being called with. That's useful for seeing what's happening. But then it's going to understand each possible request that could be passed to those web methods and send back the corresponding response type. And it's also generated a second test class. And what this one's doing is testing the constructors. These are really code coverage tests. They're not business tests. It doesn't understand what exactly that web service is doing, but it does understand the structure of what it's generated. So it's going to test all the constructors and all the methods that it's generated. And in addition to those constructors, this test method will actually use our mock, which is in that other test case, and then test calling those actual methods. So those have all been deployed, and now we have the option of testing it in two ways. It's not so common anymore, but you can actually run synchronous test cases, and the advantage of that is it's really easy to capture the debug log running under that context. So I'll get that started. And we should see in a second the debug log and our test cases and what the results of those test cases were. Perhaps a bit hard to read there, but it's run 49 test cases and they've all passed. And then it's also pulled back the corresponding log down the bottom. Now there'll be a lot of noise in there from the normal logging, so we'll filter some of that out. You should be able to see those are the debug info statements that we had the the web service mock do, so you can see it's calling all our web methods. There's another way we can run those test methods. I'll jump back to the web service output. We can run them asynchronous, which is the more common pattern now for Salesforce test cases. It's a bit harder to grab the debug log in that case, but what it will do is generate the code coverage. So we'll run that, check the status of it. Again, all 49 test cases have completed. So we can see there, if there was any problems here, they usually show up, but we've done well. We've got all our test cases to pass. And now we can actually go back, look at our class. How many lines have we got? We've got about 3,000 lines that needed to be tested to call the web service proxy. And what we can do is we can press View Code Coverage now that we've run those test cases. This is going to take a second because it's got to go off through the tooling API and pull back all the line coverage that came out of all those test cases. I think it looks like we've finished. Yeah, there we go. And then you can see it's highlighted, I'll make that a bit bigger, all the lines that were tested. And down the bottom, maybe a bit hard to read, but it's telling us that we've covered 2,260 of 2,260 lines that can be covered. So we've got 100% code coverage for the generated test classes without having to write anything. So we could actually go ahead and deploy that now quite easily. So let's move on to something a little bit harder, something a bit bigger. And again, we're sticking with web services that Salesforce already provide to us. The Metadata API is quite a useful one to be able to call from Apex. If out of the box you try and directly import the Metadata API, you're going to get a message that tells you class metadata already in use. And what that is there's a complex type within the Metadata API called metadata that has the same name as the port class itself, which is the thing you actually call out to, so they're conflicting. Our tooling will be able to detect that and give the port class a different name. The second problem that you're going to run into there is that there's about 171 objects that use what's called an XSD extension, and that's basically a form of inheritance in a WSDL. So things like custom object inherit from the metadata complex type, and they pull a number of fields from those. Our tooling is able to detect that and pull the required fields into the actual classes, so that when web service callout invoke uses them, it can have access to the required fields. Web service callout invoke doesn't understand inheritance structures in WSDL-to-Apex currently. So this is a 330 kilobyte WSDL to start with. Anyone want to guess how much Apex is needed to actually call that? Yeah. About 600,000 characters at least. Now when you've got 3 million within your normal org limit, that's about 1/5 of your available Apex code just to get the required Apex classes to call it. That's before you've written any test cases or actually even made a call out to it. So there's a big cost in bringing that entire WSDL in. So what can we do about that? Well, chances are you probably don't actually need every single method that's in that web service. If we can start chopping out some of those web service methods, we can instantly reduce the amount of generated code we need to do. If we don't generate it, we don't need to test it, so we can chop that out as well. And there may be features in certain methods that outright don't work in Salesforce, but if we don't want to call those methods, we shouldn't be penalised and we shouldn't fall over. So we might be able to skip over those completely anyway. The other thing we can do is optionally remove a lot of the supporting classes. So we can choose to chop those out if they're not needed for the methods that we're going to actually use. So we'll run another demo here. I'm going to reset this one. And we're going to start from the Metadata API. This is the current Summer 14 one. Open that up. And generate. So let's say we didn't actually need all about the 12 or 13 methods that are there. Instead, we only wanted the ones that start with the word list, of which there is one. So we'll select that. Now I should point out here, and I don't know if we'll have time to cover it, there's actually options on each method here about what to generate. So the default is just the standard web service callout invoke SOAP message. But if you wanted to, if you were doing something more difficult like read metadata, which has a polymorphic response, you can optionally generate an HTTP callout as well. And that gives you a lot more flexibility because it's going to understand how to build up the SOAP callout for you and how to process the response. But we'll stick with just the list metadata. The other thing we need to consider at this point is what are we going to do with all the extra classes that we probably no longer need? If we leave it in its default mode, it's probably going to generate most of them. We have the option here that says comment out, and it will literally comment them out. It'll still generate them, but because they're commented out, they won't count towards your limits. And the other thing we can do is we can just outright exclude them, which is what we're going to do here. So we press generate. It takes a second longer because it's got to process the entire tree to figure out what's going on. And you'll see here that our actual resulting class is a lot smaller. We're definitely not in the 600,000 line mark. We've got about 105 lines and there's 7,000 characters. So we're somewhere between 1 and 2% of the size of the original WSDL. And of course all the corresponding things like the test cases have also got a lot smaller. They're much more minimal now. So I'll deploy all those to Salesforce, again using the tooling API. And now just to prove to you that I'm not actually just deploying stuff that you can't really call, I'm going to open up some anonymous Apex. So here's some I've saved. Make that a bit bigger. This is for the Metadata API. So this is going to create an instance of that port service I just created. And then we're going to do a couple of things here. We're going to take our current session information and assign it to the session header for that Metadata API call. And we're going to tell it to call to our current domain. It's going to debug out what that endpoint is. And then we're going to put together what our list metadata query is. And I'm just going to ask for, give me all the workflow and validation rule metadata. And then finally, we actually invoke that web method that we just brought in using those parameters, and we're going to ask for them from version 31, which is the current one. So we'll run that now, and we should get a debug log back from the anonymous Apex. There's quite a bit going on there, so we'll get rid of some of the stuff from the log, get rid of the constructors. And now you can actually see, if you've got good eyesight, all our logging coming back, so that's all the methods being listed. And then also there's the callout requests and response going through. They come through as straight strings, but we can format that as XML. Makes it a bit more readable. And so it's quite useful if you wanted to examine what SOAP messages were sent out and what came back. So how does it work? Well, the process is quite linear, and it follows basically what you're seeing on screen. So you provide the WSDL in, and it will reach out and bring that down, and it will also look for any imports or includes and bring those down and manually flatten them in for you, so you don't have to go and find those for it. And then it builds up a model of metadata about that WSDL, the information it's going to need. That model is passed into a generator that generates an object model that represents what all the Apex classes, their members, and their methods are going to look like. That's passed on to a .NET technology that's called T4 templates. What that does, without going into too much detail, is transforms that object model into a string that represents the body of that Apex class. And that's ready for deployment to Salesforce. And then finally, it uses the tooling API to deploy those Apex classes to your Salesforce org if you'd like. So part of our object model, it should seem fairly familiar. We have Apex classes. Apex classes have members, collections of members and collections of methods. Methods can take parameters and return types. Return types might even be void, or they might be a primitive or an actual class. There's a couple of interesting parts here. The relationship between Apex classes and Apex class collections. At the top level, we have an Apex class collection, and that holds the Apex class that gets generated for each namespace. So from the Metadata API, we've generated a top-level Apex class to represent the namespace. And within that, we put all the Apex classes that go in that namespace. So that might be all your request and response objects, any headers. And in the case of the port that actually gets called, the port class and all the web methods go inside that as well. Another interesting part is a special type of a member that a class can have, and that's the string array Apex member. That's particularly used to hold metadata for web service callout invoke. It'll look for elements with a special type info name, and it will pull that metadata from those. The first parameter, like folder, is the name of the element in the SOAP message, and then there's its namespace. Its data type, in this case string. Now I believe web service callout invoke doesn't actually care about that anymore, but we still generate it and it doesn't seem to mind. You could put null in there as well. And then the 0 is the minimum occurrence, 1 maximum occurrence, and false is whether it's nullable or not. And there's other occurrences of this, such as the field order type info, which tells you which order to generate those to in the XML document. So how do we actually go about taking this generated Apex and deploying it back into Salesforce? Well, the tooling API doesn't actually have a concept of upserting an Apex class. Either you have an ID or you don't. If you don't have an ID, and there's nothing there with the same name currently, you're going to need to do a create. This is modified .NET code to look a bit more like something that somebody who writes Java or Apex would be familiar with. We make an Apex class for each thing we're going to deploy with a create where we don't know its ID. We give it its name, and then we assign the body of the generated Apex class to the body tag there. Put all those into a collection and call create on the tooling API. When that comes back, the only thing we have to do is iterate through the results, looking for anything that wasn't successful, and in this case we're going to throw an exception. Let's go back. There is an alternative path to this for where we don't have an ID for the class. What we could actually do is just create a stub class with no body but the correct name, and then use that as a way to get the ID that we can pass along to the metadata container. The advantage of using a metadata container is that you can put a whole bunch of classes in the request at once for processing, and so it will understand the dependencies between those classes. So if you've got a test class that depends on the actual implementation being there, you can't deploy that until the other one's there. But with the metadata container approach, you can push them all up in one request and compile them all at once. So the metadata container is going to sort of contain all the work that we're going to do in this job. You need to give it a name, and the name needs to be 32 characters or less, just something unique. I've just put the date in there. So you create that and again check for the response, make sure it was successful, and you're going to need to hold on to the ID of that record you just created for some of the subsequent callouts. So now you're going to map all your Apex classes into what's called an Apex class member. Pretty much the same thing as an Apex class, except it can have a reference to the metadata container that we just put in. So let's have a look. So yeah, the top line, we're going to assign the ID of the class that we already know what it is. We'll put the body of the T4 template in, give it its Apex class name, its same, and then assign it back to the Apex class that we knew before. And then we take that array of Apex class members and call create, and again check for the results to make sure that it was successful. But at this stage, we haven't actually deployed anything. We've just got the data up there. So we need to create a container async request, link it to the same metadata container so it knows what it's deploying. And then we need to tell it, are we doing an actual deployment, or do you just want to validate this? And that can be quite handy. In those earlier steps, I showed you there's a little deploy button next to each Apex class. There's a drop down there and you can just say validate, and so you can make changes and it will tell you what the results of those changes are without actually making them. So we create our container async request and check for a success, raise an exception, and then we need to sit and poll the container async request at some interval to see what's actually happening. It'll sit in a queued state, and when it's no longer queued, it's either going to be failed or success. If it did fail, the deploy details will contain all the useful information there about what actually went wrong and on what line, so that's really quite useful. And then all going well, we've deployed, and we can just delete our metadata container because we no longer need that anymore. Now, I'd like to say that we'd be able to handle any possible WSDL that you could ever throw at it, but the reality is the more WSDLs I see, the more crazy ways they seem to be able to be put together. Some things web service callout invokes simply can't handle. You might be looking at something like Apache Axis that might generate arrays with external references to other elements within that SOAP message. Again, polymorphic responses aren't directly supported. So one option there is you can use the HTTP callout option on the web methods. That gives you the ability, it'll generate the code, you might need to modify it a little, but it will get you a lot of the way there with very little effort. And sort of like my metaphor here, if it's just outright broken WSDL, if it's not valid XML, we're not going to be able to put it back together for you, so that it'll fail. And if you do have an interesting or unique WSDL, we'd like to hear about it. You can send it through to us at fuseIT.com/WSDLhelp. Actually sending your WSDL to us is really helpful so that I can look at it. A lot of WSDLs are behind firewalls, and if I can't see it, I can't really understand what's wrong with it. So, in summary, dealing with WSDL imports can be really time-consuming if something goes wrong, and it really diverts you from the task that you're interested in achieving. With our extended tooling, we can bring in a lot of extra support in without having to use anything beyond web service callout invoke. So we can handle imports, includes, and extensions. We can generate basic code coverage, which could save you a lot of time, get you to the point where you can deploy it quicker. And then if you don't need all the methods, we can use method filtering and greatly reduce the amount of code generated. We'll do Q&A, but before I start that, I just wanted to point out a few things. There's the URL at the top again if you want to download it, fuseIT.com/explorer. While I've got your attention, I'd like some votes on an idea I've raised on Salesforce, which is the ability to run anonymous Apex as if it was a test case. I think there'd be some really good advantages to this. You could, assuming you could run a test context in anonymous Apex, you could call an individual test method from a large collection in one class. And that would have some nice advantages. You'll be able to see the logging from just that method without having to see everything else that's going on there. And of course, it's got other nice things. You can just write some anonymous Apex, run it, maybe even against a production org, and it'll have no side effects because it's a test case. So any votes would be appreciated for that. About 2 weeks ago, Salesforce open sourced their WSDL-to-Apex generator. It's on GitHub. I've put a few pull requests into that. So that's another good option. That's Java-based. You can compile it, run it yourself as a little command line. And I believe it's going to be embedded or integrated into the force.com IDE as well. So that can be a good place if you need to, if you actually want to modify their code, and they'll roll that back into their product. I don't believe that's going to become part of the web version that's currently there. I believe that's going to stay static. So any changes that made there, you'll need to get in the force.com IDE. There's a session tomorrow, I believe, called Building Callouts Without WSDL-to-Apex and Apex Parsers. I don't know much other than the title or what's in the thing, but it sounds applicable and interesting. Finally, I'd like to say thank you to Garisha Aurora, who, as an intern, built a lot of this tooling that we've used today. Thank you. Any questions? Do you want to use the mic so the recording can pick it up?
Presentation, great tool.
Thank you.
Does it run on a Mac?
I believe people can use Wine. Can you use Wine on a Mac? Somebody's used Wine in Linux, and I have seen it running out of Windows.
Okay.
But there is also a web-based version of that WSDL-to-Apex. It's not as advanced, but it will do the generation, and you can get that from the same place.
Thank you.
Hi. Great tool, and your website is really good too. Before they open sourced the WSDL-Apex generator, did Salesforce work with you at all to show you how they generated the WSDLs at all?
No, I reverse engineered it. I basically looked at all sorts of examples of WSDLs and then tried to generate exactly the same code that Salesforce was generating. So the biggest sample of WSDLs I have, if you send me your WSDL, I might add it to that bunch of test cases to make sure we can generate the same thing.
It's good now that it's open source, because that was reverse engineering it for me. It took forever. So appreciate the work. So.
Yeah, 2 weeks before Dreamforce. This session was well ready before then, and now 2 weeks before Dreamforce, they open source theirs.
Hi. Do you know if there's any roadmap now that WSDL-to-Apex generator is open source?
Roadmap for Salesforce or roadmap for our stuff?
For the Salesforce one, or
I don't know exactly what Salesforce are doing with them, their one. I do know that they plan to embed it in the force.com IDE, or that's what they said in their blog post. And I do know that they initially said they weren't going to roll those changes back into the web version. So you can't just go Apex class generate from WSDL. You'll still be using the old one there. But that's just what they said in the blog post, so I don't work for Salesforce.
Okay, thanks.
They could do whatever they want. Oh, has anybody used Salesforce Stack Exchange? I can't do anything right here, but if you want to find me afterwards, I might have something. But I'm told I'm not allowed to give stuff out. So, cool. Thank you.